Alright, so this question says a bag contains 5 blue marbles, 4 white marbles, and 3 red marbles. If 3 marbles are randomly selected from the bag, what is the probability that all the 3 marbles selected will have the same color? Alright, okay, so there's 3 ways to do this, right? Because there are 3 different colors. We can either pick blue, 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 or we can pick white, 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 or we can pick red, red, red. Those are the 3 possible things you can pick. So what's the probability of picking blue, blue, blue? Well, the probability of picking blue the first time is, well, there's 5 blue marbles out of a total of 5 plus 4 plus 3, which is 12 total marbles. So that's the probability of picking blue the first time. 5 out of 12 because there's 12 marbles total and 5 of them are blue. Well, the second time we pick a blue marble, there's not 12 marbles in the bag anymore. There's only 11 because we already picked one. So we also already picked 1 blue marble, so now there's 4 blue marbles left out of 11. And then we pick, 1 more, and now there are 3 blue marbles left, and there are only 3 plus 4 plus 3 equals 10 marbles total in the bag. So the probability of picking blue, blue, blue is going to be 5 12s times 4 11s times 3 10s. And again, the reason we're multiplying this is because, first we have to get that first blue marble, and then of that chance, it's a 4 11s chance that we pick, the second blue marble, and then of that chance, there's a 3 10s chance that we pick that third marble. So we're going to apply the same concept to our other triples. So for white, 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 well, we can follow the same pattern with the denominators because we know that it'll start out with 12 marbles in the bag, and then we'll pick one, and it'll go to 11, and then we'll pick another one, and it'll go to 10. So how many white marbles do we originally start out with? 4. And then we'll have 3, and then we'll have 2. Same logic for red. We start out with 3 out of the 12 marbles being red, and then we pick one. So 2 out of 11 in the bag end up being red, and then 1 out of 10 are red. So now we need to just add up all of these probabilities to find the probability that all of those 3 marbles selected will have the same color. Okay, so is there any way we can simplify this, just kind of universally? We can divide each 10. So this 4 will divide by 2, and this 10 will divide by 2. This 4 will divide by 2. Actually, let me just get rid of this 2 here. This 10 will divide by 2. And then we'll get rid of this 2 and divide this 10 by 2. So the numerators and the denominators, we're doing the same thing to both of them, so we're allowed to do that. Is there anything else? Well, we can cancel out a 3 and a 12. 3 12ths becomes 1 over 4. Same thing here. Same thing here. That's 1/4. So now this is a lot easier to work with because we have 4 times 11 times 5 on the bottom. So that's 20 times 11, which is 220 on the bottom. On the top, we have 5 times 2 here, which is nice. It's 1/22. I don't know if that'll help us. And then for this one, we have 4 over 220 on the bottom. And then for the last one, we just have 1 over 220. So adding all of these up, we have 10 plus 4 plus 1. So that's 15 over 220. We can simplify this and divide everything by 5. So that'll give us 3 over 220 divided by 5. Why am I blanking? 44? Yeah, it's 44. So this should be the probability that all those 3 marbles selected have the same color.